Tiga. Assalamualaikum warahmatullahi wabarakatuh. Good morning all.
Good morning.
So today, Hanivan is still unable to attend because he is sick. So let's go. Today I want to explain about operating system. An operating system or OS is a group of computer programs including device drivers, kernel, and other software that lets people interact with a computer. It manages computer hardware and software resources. It provides common service for computer programs. An OS can be small like Manuet OS or large like Microsoft Windows. Different operating systems can be used for different purposes. Some are used for everyday things like a personal computer. Others are mobile operating systems or are used for specialized work. An operating system has many jobs. It makes sure that all the programs can use the CPU, system memory, display, input devices, and other hardware. Some also give the user an interface to use a computer. An OS can also responsible for sending data to other computers or devices on a network. Some example of commonly used operating system are Mac OS, Linux, and Microsoft Windows. History. The first operating system was used in the ENIAC, electronic numeral integrator and computer. It was very hard to make ENIAC do work. How the operating system worked was based on how the switches and the cables were put together, and depending on these factor punch cards would make a result. Well, this was an operating system of a kind, it is not what is though as one of modern times. The first operating system that look and feel like operating systems in modern age was Unix, made in 1969 by Bell Labs. It had a small kernel and many tiny programs that could be put together to work with user input and data. Many of its features were taken from Multics, an older operating system made in 1964. Type of operating system: single and multitasking. A single tasking system can only run one program at a time. A multitasking operating system can run more than one program at the same time. Multitasking is done by dividing processor time. The processor gives a little bit of its time to each program. Single and multi-user. Single-user operating systems cannot be distinguished between users, but may allow multiple programs to run simultaneously. A multi-user operating system permits multiple users to interact with the system at the same time. A distributed operating system manages a group of distinct computers and makes them appear to be a single computer. Distributed computations are carried out on more than one machine. Templated. In an OS, distributed and cloud computing context, templating refers to create a single virtual machine as a base operating system, then saving it as a load as a tool for multiple running virtual machines. The technique is common in large server warehouses. Embed, embedded, embed operating system are designed to be used in embedded computer systems. They are designed to operate on a small machines like PDAs with less autonomy and are able to operate with a limited number of resources. Windows CE and Minix 3 are some expression of embedded operating system. Real time. A real-time operating system guarantees processing of event or data by specific moment in time. A real-time operating system may be single or multitasking, but when multitasking, it uses specialized scheduling algorithms so that deterministic nature of behavior is aside. An event-driven system switches between tasks based on their priorities or external events, while time-sharing operating systems switch tasks based on clock interrupts. Library. A library operating system is one in which the service that are typically operating system provides, such as networking, are provided in the form of libraries and composed with the application and configuration code to construct an unique kernel specialized single address space machine image that can be deployed to cloud or embedded environments. A computer program. A computer program is a list of instructions that tell a computer what to do. Everything a computer does is done by using a computer program. Program stored in the memory of a computer or internal programming let the computer do one thing after another, even with breaks in between. John von Neumann, a mathematician born in Hungary, came up with this idea in the late of 1940s. 1940s. The first digital computer designed with internal programming capacity with the ADFAC, which means electronic discrete variable automatic computer, built in 1949. Some explains of computer programs are operating system. A web browser like Mozilla Firefox and Chrome can be used to view web pages on the internet. An office suite can be used to write document or spreadsheet. Video games are computer program. A computer program is stored as a file on the computer's hard drive. When the user runs the program, the file is read by the computer, and the processor reads the data in the file as a list of instructions. Then the computer does what the computer program tells it to do. A computer program is written by a programmer. It's very difficult to write in the ones and zeros of machine code, which is what the computer can read. So computer programmers write in a programming language such as BASIC, C or Java, Once it is written, the programmer uses a compiler to turn it into a language that the computer can understand. There are also bad programs called malware written by people who want to do bad thing to a computer. Some are spyware trying to steal information from the computer. Some try to damage the data stored on the hard drive. Some others send the users to websites that offer to sell them things. Some are computer viruses, or ransomware. Okay, that's all. Mutiara, can you continue? Can continue.
Okay, thank you, Aswin.
Okay.
Yeah, great work. So I will explain about what is a REST API. REST or RESTful API design representational state transfer is designed to take advantage of exciting protocols while REST can be used over nearly any protocol. It usually takes advantage of HTTP when used for web. This means that developers do not need to install libraries or additional software in order to take advantage of a REST API design. This API design was defined by Dr. Roy Fielding in his 2000 doctorate dissertation. It is notable for its incredible layer or of flexibility. Since data is not tied to method and research, REST has the ability to handle multiple types of call, return different data formats, and even change structurally with the correct implementation of hypermedia. This freedom and flexibility inherent in REST API design allow you to build an API that meets your needs while also meeting the needs of very diverse customer. Unlike HOAP, REST is not constrained to XML, but instead can return XML, JSON, YAML, and any other format depending on what the client requests. And unlike RPC, users aren't required to know procedure names or specific parameters in a specific order. However, there are drawbacks to REST API design. You can lose the ability to maintain state in REST, such as during session. It can be more difficult for newer developers to use. It's also important to understand what makes the REST API RESTful and why these constraints exist before building new API. After all, if you do not understand why something is designed in the manner it is, you can hinder your efforts without even realizing it. Understanding REST API design, while most API come to be RESTful, they fall short of the requirements and constraints asserted by Dr. Fielding. They are 6K constraints to REST API design to be aware that when deciding whether this is the right API type for your project. Client server. The client server constraint works on the concept that the client and the server should be separate from each other and allow to evolve individually and independently. In other words, I should be able to make change to my mobile application without impacting either the data structure or the database design on the server. At the same time, I should be able to modify the database or make changes to my server application without impacting the mobile client. This creates a separation of concern, letting each application grow and scale independently of the other and allowing your organization to grow quickly and efficiently. Stateless REST API are stateless, meaning that calls can be made independently of one another, and each call contains all of the data necessary to complete itself successfully. REST API should not rely on data being stored on the server or session to determine what to do with a call, but rather solely rely on the data that is provided in that call itself. Identifying information is not being stored on the server when making calls. Instead, each call has necessary data in itself, such as the API key, access token, user ID, and this also helps increase the API's reliability by having all of data necessary to make the call instead to rely on a series of calls with server state to create an object, which may result in partial files. Instead, in order to reduce memory requirement and keep your application as scalable as possible, a RESTful API requires that any state is stored on the client, not on the server. Change because stable API can increase request overhead by handling large load of incoming and outbound calls. A REST API should be designed to encourage the storage of changeable data. This means that when data is changeable, the response should indicate that the data can be stored up to a certain time, or in case where data needs to be real time, that the response should not be caged by the client. By enabling this critical constraint, you will not only greatly reduce the number of interactions with your API, reducing internal server usage, but also provide your API user with the tools necessary to provide the fastest and most efficient apps possible. Keep in mind that caching is done and on the client side, while you may be able to cache some data within your architecture from to the to perform overall performance. The intent is to instruct the client on how it should proceed and whether or not the client can store the data temporarily. Uniform interface. The key to the decoupling client from serving is having a uniform interface that allows independent evolution of the application without having an application service models and action tightly coupled to the API layer itself. The uniform interface lets the client talk to the server and a single language, independent of the architectural backend of either. This interface should provide an unchanging and standardized means of communicating between the client and the server, such as HTTP, with URI search, CRUD, create, read, update, delete, and JSON. Layered system. As the name implies, a layered system is a system comprised of layers, with each layer having a specific functionality and responsibility. If we think of the model view control framework, each layer has its own responsibility with the models comprising how the data should be formed, the controller focusing on the incoming action, and the view focusing on the output. Each layer is separate but also interact with the others. In REST API design, the same principle holds true with different layers of architecture working together to build a hierarchy that helps create a more scalable and modular application. Code on demand, perhaps the least out of the six constraints, that the only optional constraint code on demand allows of code and applets to be transmitted via the API for use within the application in essence. It creates a smart application that is no longer so solely dependent on its own code structure. However, perhaps because it's ahead of its time, Code on Demand has struggled for adoption as web APIs are consumed across multiple languages, and the transmission of code raises security questions and concerns. For example, the directory will have to be writable, and the firewall would have let what may normally be restrict content truth. So maybe that's all I can say. Thank you for all your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.